All right, today we are on the B part of yesterday's lesson. We're still graphing sine and cosine curves. So a lot of the material from the previous day will carry over. How to find the period, the incidence, the amplitude, all that good information. What's different, or what you're going to see that's changed on the graphs, is now they're going to be moving left, right, up, and down. We're going to have those transformations. So we're going to have to talk about those a little bit. So some nice, easy, quick warm-up problems on some functions we're used to. First one, of course, a quadratic with the x squared. Describe the transformation from f of x equals x squared to g of x equals x squared minus 1. Clearly, they've added this minus 1 on it. Remember, if you add or subtract something from the back of the function, it moves it up or down. Minus 1 moves it down 1. Okay, describe the transformation from f of x equals x squared to x minus 1 in parentheses squared. So now you're subtracting the 1 from the x inside the parentheses. So that is a horizontal shift, a left or right shift. Minus 1 is going to move it to the right 1. So just some quick review from Algebra 2. I know you do a lot of transformations back there. You will see that, of course, happening today on our graphs. All right, so let's just review here quickly. I'm going to fill out the things, of course, that we started off in the previous lesson. Amplitude, remember, absolute value of A. A is our lead coefficient there, so the absolute value of 1, of course, 1. Period, 2 pi divided by B. I'm just going to jot that down here. So it's in front of us. B, of course, is your coefficient on x. So I'm going to have 2 pi over 1, which, of course, 2 pi. Increment is your period divided by 4. So now I'm going to do 2 pi divided by 4. We're going to reduce 2 over 4 to a half. So that's how we're going to be scaling our graph by 1/2 pi. Now, phase shift. This one does have a phase shift, meaning you are moving the graph left or right. To figure out that amount, just like on that last warm-up problem, it's going to be the opposite of whatever you're adding or subtracting to x. So the opposite of minus pi over 4, positive. So it's moving it pi over 4 to the right. So we are shoving the graph to the right 1/4 pi. You're going to see that when we draw it. Now, there is no plus or minus any values at the back of it, so there's no vertical shift. We're not moving it up or down. So our center line is still just the plain old boring x-axis, which always has the equation y equals 0. All right, let's set it up like we've done our previous graphs. Again, I'm going to try to draw it to scale. No promises. So our amplitude, of course, is 1, so I'm going to go up 1, down 1. Here's what's different. I am not starting at 0, 0. We have the phase shift. We are starting our graph here at pi over 4. So my first little tick mark, I'm going to put pi over 4. To get 2 full periods, we need 8 more increments from our starting point. I think it's just going to be easier to do all 8 to the right. I can just keep adding, and hopefully it will go rather quickly. We're scaling by 1/2 pi, so I'm going to try to make these a little wider. Again, try to draw it to scale, no promises, but I need 8 of them. So there's 1, 2, 3, 4, 5, 6, 7, 8. I'm just going to extend this out a little bit. There we go. Okay, now, sine, of course, always starts at the center line, so I know I'm starting right here. I'm going to put a little note that that's where I'm starting. I do not require you to do that on your homework. I'm just doing it so you know how I'm drawing it. We can clearly draw the sine curve from here because it's going to, of course, be the hill in the valley. Positive 1 lead coefficient. But before I get into drawing it, I need to label all of these different increments. So we're going to have to do a little bit of fraction work. I'm going to write it out on the bottom. You might be able to do it all in your head. We are starting at pi over 4. And we're scaling it by pi over 2. So I got to do a little fraction work here. 1/4 plus a half, I can do that in my head. 1/4 plus a half, 3/4. So that's my next one. Okay, scaling again by 1/2 pi. So now I'm going to add another 1/2 pi to that. Now, some of you might be able to do that in your head. 3/4 plus 1/2, or 2/4, 3/4 plus 2/4, 5/4. That's my next label. Just going to keep on going. I'm going to add another increment, another pi over 2. So 5/4 plus 1/2, or if you like common denominator, 1/2 is 2/4. 5/4 plus 2/4, 7/4. Now, from here, you should be able to see a pattern happening. I'm not going to get crazy and keep adding and doing all of this work, because clearly we can see what's happening is our numerators are going up by 2 every time. So I just know the next one's going to be 9 pi over 4, add another 2, 11 pi, 13 pi, 15 pi, and last but not least, 17. So it's important that we label all of the increments, of course, accurately. So now I'm going to actually draw the sine curve. We're starting here at pi over 4. We're at the right, of course. Positive 1 was our lead coefficient, so we're starting up at 1. So there's my hill, now my valley. So this is one complete period of sine. I'm going to, of course, continue on. I should have another hill, there it is, and another valley. And again, I did both periods to the right. You could have subtracted a half a pi and gone to the left. It doesn't matter to me how you fit them on there, and it just kind of depends on where my starting point is, what I'm going to do. As long as you have 2 full periods graphed, that's what I'm after. All right, let's take a look at this one. We got a phase shift and a center line shift, all sorts of good stuff here. So amplitude, absolute value of A, so 3. So it's going to be taller than the last one. Period, 2 pi over b. b is the coefficient on x, so 1, 2 pi over 1. Increment, period divided by 4. So 2 pi divided by 4 is going to reduce to pi over 2. So that's all stuff we know, nothing exciting there. Phase shift, we know we have it because you're adding or subtracting something to x. It is the opposite of that. Basically, you're solving that for x. So negative pi. So we're going to start at the left this time. And we have a center line change because we are moving it down 3 units. So my center line is going to be down at negative 3. So this is going to be a fun one to draw. So here we go. So again, just I'm going to set it up. Draw my x and y axes. Okay. So the first thing I'm going to mark on here, of course, is my new center line, down at negative 3. 1, 2, 3. I'm going to put a little dash center line on here. Try to draw neat, but well, you know my drawing skills. Now, from my blue center line, our amplitude is 3, so I'm going to be 3 above that, 1, 2, 3. So here's going to be the highest point of my curves I'm going to draw, then 3 below the center line. So we're going to draw these curves between 0 and negative 6. It's moved down to the bottom. So there is the transformation down 3. That's going to cover that. Now, phase shift. We're also moving it to the left, negative pi. So I'm going to start out here at negative pi. Sometimes it's a little bit of a guessing game where to put negative pi. I'm going to start here. If I get it kind of where it's too congested and going to be hard for me to squish it in, negative pi to 0, I can erase it and I'll move it where I need to do. So here we go. We need 8 increments, of course, for 2 full periods. I'm going to do all 8 to the right. I'm worried if I go to the left, I'm going to run out of room clearly. So my next one, so I'm starting at negative pi, I'm going to add half a pi. So negative 1 plus a half is negative a half. Okay, I think I can fit that in there, okay? If I couldn't, I'm going to erase it and move it to the left. Then I'm going to add, of course, another period. So our period, of course, or excuse me, our increment. Another pi over 2 puts me at 0. So red dot's going to count as 1. My next, I'm going to keep on going. We're going to add another pi over 2. 0 plus a half, a half. I think I can pretty much go mental math here because a half plus another half, 1. I can do that in my head. So right now I have 1, 2, 3, 4 periods, 4 increments. There's 1 period, so I need 4 more. And I'm just going to keep adding the half a pi in my head. So 1 pi plus another half, 1 and a half. I'm going to write it in proper. 1 and a half plus a half. 2 plus another half, 2 and a half. I'm going to put it in proper again, just a little easier to fit it in the space. 2 and a half plus a half, 3. Now, the key is, 1, it's a cosine curve. 2, our starting point. So remember, we have these phase shifts. We went to the left, negative pi. We also have the vertical shift of down to negative 3. So think of this little starred point as your new 0, 0. Left to negative pi, down to negative 3. Now, cosine, of course, starts at the amplitude. So I'm not going to put my starting point on the star. We start at the A, the value of 3. So I'm going to go up to 3. So here's where I'm starting. Again, you don't have to write the word start on yours, just so you know. My maximum height, I'm back to the center line. I'm down 3. I'm back to the center line. I'm up to pi. So remember, cosine is one big valley. There's one period of our cosine curve. And I'm going to continue on. Back to the center line, down 3 more units, back to the center line, up 3. So there is my second valley. Got it. So there is our cosine curve. All right, lots of transformations, lots of shifting. So let's take a look at this one. We've got a phase shift, of course. We're adding something to x and a negative for our lead coefficient. So we're going to have a reflection. So let's get all of this drawn. Amplitude, absolute value of a. Absolute value negative 2, 2. Period, 2 pi over b. b, of course, is 4. 2 pi over 4, I'm going to reduce it. Increments, the period divided by 4. So, of course, you could do that in your calculator, but if we're going to divide by 4, we end up multiplying by the reciprocal. So pi over 8. Okay, we do have the phase shift. So again, it's like you're solving this expression with x. You're setting that to 0 and solving that in your head for x. You'd have to subtract off the pi and divide off the 4. Or of course they call it c over b. But you're solving for x. No up and down movements at all. Nothing added or subtracting to the end. So we're staying right on the x-axis. Y equals 0. Okay, let's get it set up. Okay, so I'm going to do our amplitude, of course, first, height of 2. So nice and simple there. Now, phase shift. We are starting at negative 1/4 pi. Now again, where do I put that on the left side? I might have to erase it and move it. We'll just see how it goes. I'm going to put it in here. That looks about right. Okay, so that is where we're starting at. And we're going to increment by 1/8 pi. So I'm going to add 1/8. Now again, you could do the fraction work, negative 1/4 plus 1/8 in your calculator, and just put the pi on it. Or of course, I think of 1/4 as 2/8. So negative 2/8 plus 1/8, negative 1/8. I think I can fit it. It might look a little messy. I might erase it here. I don't know. Negative 1/8 plus another 8. We're scaling by an 8. 0. I think I can fit it. It looks like it will fit. I'm going to work with it. I'm going to go with it. Okay, so 0 plus an 8th. I can do that one in my head. So remember, I need 4 to make a full period. I have 1, 2, 3, 4. An 8th plus an 8th would be 2/8, which I'm going to reduce. So I need 4 more. I'm going to go to the right. So I left off at 1/4 or 2/8. 2/8 plus an 8th, 3/8. 3/8 plus an 8th, 4/8. I'm going to reduce it. 4/8 plus another 8, 5/8. 5/8 plus one more 8, 6/8. Again, I'm just going to reduce it. Got it. So our starting point for sine, of course, we started on our phase shift down here at negative pi over 4. Remember, sine starts on the center line. Now, this time, though, we have that negative, that reflection in the front. So it's not going to be a hill and a valley. It's going to be a valley and a hill. Or AKA, we're going to start by curving our graph down first. Back to the center line. Up to center line. So here's my valley, hill. Again, I'm just going to continue on with my drawing. Down to center line. Up to center line. So valley, hill. Got it. And again, I don't expect you to write the word start on yours. I'm just doing it to try to help you out. All right, one last graph. Here we go. Amplitude. Now, notice they kind of messed up the order on this problem for you. We're used to our function in the front, the 1 in the back. So mentally picture that. If it helps, you can rewrite it down here. And then plus 1, if that helps. Amplitude, of course, your coefficient, absolute value of a half. So it should be shorter in comparison to the other graphs we've drawn. Again, no promises here as we are freehanding these. Period, 2 pi over b. Now, this time they're using t for your variable. Fine. Our coefficient on it is 4 pi. 2 pi over 4 pi, of course, reduces to a half. Now don't let it scare you that you don't have a pi on there. Remember, pi is simply a value, 3.14. It's simply a number, okay? So it's all right. Increment, period, divided by 4. So a half divided by a 4 is 1/8. Phase shift. We are not adding or subtracting anything to our t, to our variable, so we don't have one. So I'm just going to put none. You could cross it off, whatever. Now, our center line is changing because we have this +1 at the back. That's our vertical shift. So it's going to move it up to 1 or up 1 unit. So here we go. So draw your x and y axes. Okay. First thing I'm going to draw, since we have a new center line, is I'm going to start with that. So I'm going to start at 1 here. Mark that out. Now, from our new green center line, I'm going to label our amplitude. We're going to go up a half a unit from there. So if I start at 1, I went up a half, I'm at 1.5. And then I'm going to go up a unit. 1 minus a half, a half. So I'm going to draw this in between those red tick marks of a half and 1.5. We're moving it up there. So that's where that's going to go. Now, nice, there's no phase shift. I'm super happy about it. So we're just starting at 0. This time I'm going to do 1 period to the right, and I'm going to go 1 to the left. I guess we haven't done 1 to the left here today, so let's do 1. We are scaling our graph by 1/8 pi. An eighth plus an eighth, 2/8. We're going to reduce. 2/8 plus an eighth, 3/8. 3/8 plus an eighth, 4/8, or a half. And then, of course, you have the negatives. You're subtracting them. Subtract an eighth, subtract another eighth, subtract 1 more eighth, and subtract another eighth. Okay, so where are we starting? We are starting our curve, of course, up here, our new center line, but it's a cosine curve. So we are starting, of course, at the amplitude. I'm starting up here at 1.5, my maximum height. Back to my new center line. Half a unit, back to the center line, up a half. So there's my one big valley, period, for cosine. I'm going to draw the exact same curve on the left side. So I'm at my max height up here, so I'm just back to my new center line, down a half, center line, up a half. There's going to be my second big valley. Got it. So a little more tricky than the previous day because you have these transformations up, down, left, right, but be careful with the fractions. I have faith in you. Have a great day.